Okay. Welcome to another video. So in this question, they have given a retaining wall which is having a height of 10 meter and it is filled with clay as the backfill, and in front of the retaining wall also they have given the 2 meter layer of clay as the in the front of the retaining wall. So they have given the properties of backfill and front fill are the same, right? And they have given the interface angle between the base soil and base of the retaining wall, which is base soil and base of the retaining wall. So the weight of the retaining wall is nothing but 5000 kilonewton, and the interface angle is given by 20 degrees, right? Yes. So the interface angle between the base of the retaining wall and base soil is 20 degrees, and the depth of clay layer in the front they have given us 2 meter. Okay. So they have told that the tension crack is filled with water, right? So they have told us to assume that the tension crack is filled with water. And using Rankin's earth pressure theory, they have asked us to find out the factor of safety against sliding failure. So we need to find out the factor of safety against sliding failure, right? So if you draw the pressure distribution diagram of this retaining wall, it will be something like, sorry, it will be something like this. Okay. So this zone where the tension crack occurs. So if you reform the pressure distribution of these two zones, you will get the pressure distribution as, and for this zone the pressure distribution will be like this one, right? Where the base of this top zone will be gamma naught z, and height will be nothing but zc. Sorry, base will be gamma w z zc. Height will be zc because this is the critical depth of failure, right? And with consideration of this tension crack, the pressure distribution diagram will be just like this, where the active earth pressure at the top will be 0, and bottom it will be Ka gamma H minus 2C root Ka. And this height will be nothing but H minus Zc, right? So we have to find out the total pressure distribution of the retaining wall per meter length, which gives, we will find out the value of Ka first. Ka will be 1 minus sine pi divided by 1 plus sine pi. 1 minus sine 0 divided by 1 plus sine 0. The value of angle of internal friction for clay layer they have given us 0, right? With this we can find out the value of Ka as 1. And the depth of tension crack, which is nothing but Zc. So Zc will be equal to 2C divided by gamma root Ka, where 2C, 2 into 30 divided by gamma, which is nothing but 17.2 root Ka, where we will get 3.488 meters. Therefore, total active earth pressure due to soil and water, because they have told that top layer the tension crack is filled with water. So this zone it is filled with water and niche it is filled with uh, clay. Okay. So we'll calculate the total earth pressure, which is nothing but 1 by 2 into Ka gamma h minus, because half into base into height, right? Ka gamma h minus 2c root Ka into height is nothing but h minus zc plus pressure distribution, area of pressure distribution of top layer, which is nothing but 1 by 2 into gamma wzc into zc. So we will get 1 by 2 into Ka, which is nothing but 1 into saturated weight of clay layer, which is nothing but 17.2 into h. H will be nothing but 10 meters. H will be nothing but 10 meters minus 2 into the value of C. It is 30 root Ka is nothing but root 1 also into 10 minus Zc, which is nothing but 10 h minus Zc. 10 minus Zc is nothing but 3.488. 3.488, right? Plus half into 9.81 into Zc, which is 3.488 into 3.488. By solving this, we get the total active earth pressure will be Pa will be 424.347 kilonewton per meter square. Sorry, kilonewton per meter. Right. Yes, kilonewton per meter. So the active earth pressure acting on the retaining wall, Pa, which is nothing but Pa, which is nothing but 424.347. And the frictional resistance of the wall will be acting in the negative opposite direction. Right. So if you see the diagram, if you see this portion, we can find out this value. That is frictional resistance Fr. So Fr will be nothing but Fr will be W tan theta. So W, which is 5000 tan 20, which gives 1819.851. The frictional resistance is, which is 1819.851 kilonewton. Right. With this, we can find out the factor of safety. So factor of safety, which is resisting force divided by actuating force. Resisting force, which is nothing but 1819.851. Actuating force, which is nothing but 424.347. So finally we get 4.289, which is 4.29 or 4.3. 4.29. In this question, they have given the vertical and horizontal effective stress, and they have asked us to find out the condition for the soil element to reach the failure state using Rankine's passive earth pressure condition. So to reach failure state, Rankine's passive earth pressure coefficient Kp should be greater than 1. Right. So Kp is nothing but sigma h by sigma v should be greater than 1. Therefore, sorry, therefore sigma h should be greater than sigma v, or sigma h dash should be greater than sigma v dash. So option A is the right answer. In this question, they have given the smooth vertical retaining wall with backed up by two layers of different soils, and they have given the properties of two soils. So they have asked us to find out the active earth pressure at the base of the wall. Okay. They have also given the surcharge of 20 kilopascal. So the active earth pressure at the base of the wall will be nothing but PA will be equal to Ka into gamma H plus Qt minus 2C root Ka. Without surcharge, we won't calculate the value of Qt, but with surcharge, we have to calculate the value of Qt, where Qt is nothing but Q plus pressure distributed by layer 1, right? Q plus pressure distributed by layer 1 will be nothing but sigma gamma z. Okay, z is 3 meters. So Q is 20 kilopascal plus gamma z. Gamma will be equal to 18 into z3, which gives you 74 kilonewton per meter square. The value of Ka will be equal to 1 minus sine pi divided by 1 plus sine pi. So for the active earth pressure at the bottom, we have to consider the angle of internal friction as 25 degree. So 1 minus sine 25 divided by 1 plus sine 25. From this we will get the value as 0.406. Right. So if you find out the value of gamma h is nothing but gamma, that is 19 into h, which is 4 meter, which gives you 76 kilonewton per meter square. Gamma h, we are considering it for layer 2, right? Yes. Now we'll solve all this in the equation. So PA will be equal to K is nothing but 0.406 into gamma h 76 plus QT, which is nothing but 74 minus 2 into C. The value of C is nothing but 20 kilopascal. 20 into root Ka. Root Ka is nothing but root of 0.406. By solving this equation, we get the active earth pressure PA will be equal to 35.41 kilonewton per meter square. So they have asked us to find out until one decimal place, which will be nothing but 35.4 kilonewton per meter square, which is 35.4 kilopascal. If you see this question, they have told that as per Rankine's theory of earth pressure, the inclination of failure planes, that is 45 plus pi by 2 degree, with respect to the direction of minor principal stress. The above statement is correct for which of the following options? They have said that it is only correct for active state and not the passive state. It is only correct for passive and not the active state. It is right for both active as well as passive states, and it is neither active for or nor passive states. So if you see the minor principal stress for active earth pressure, the minor principal stress will be nothing but it will be looking like this, where the direction of minor principal stress will be like this. Direction of minor principal stress, right? And it will be inclined with the 45 plus pi by 2, where this one will be vertical stress and this one will be horizontal stress for active earth pressure. And for passive earth pressure, the direction of minor principal stress will be in this direction. It's responding to horizontal vertical direction, right? And this one will be gamma h, this one will be gamma v, where angle will be linking to 45 plus pi by 2, right? So this one is for passive earth pressure. Therefore, it is applicable for both active as well as passive states. In this question, they have given that a vertical trench is to be excavated in a clay soil deposit which is having a surcharge load of 30 kilopascal. They have also said that a fluid of 12 kilonewton per meter cube unit weight is poured into the trench to prevent the collapse as excavation proceeds. Right. And they said that fluid is not seeping through the soil deposit. The fluid is not seeping through the soil deposit. Right. So they have given the parameters of the clay and they're asking us to find out the maximum depth of unsupported excavation. Right. If you draw the pressure distribution diagram, it will be something like this one. Right. This one is pressure distribution diagram में clay deposit due to soil. So the hydrostatic pressure distribution diagram will be nothing but like this one. So hydrostatic pressure distribution diagram will be, wait. So hydrostatic pressure distribution diagram will be nothing like this one. Okay. So the fluid is having a unit weight of 12 kilonewton per meter cube. And the total height of the trench is, they have given the total height of the trench, that is h, right? And it is acting, surcharge load is acting, which is Q will be equal to 30 kilopascal. So this one will be ZC and this one will be H minus ZC. Right. Now the active earth pressure at depth Z, which means active earth pressure at bottom, PA will be equal to Ka gamma H minus 2C root Ka minus 12Z plus Ka cube. So due to surcharge, it will be nothing but Ka into gamma H plus Q minus 2C root Ka. Since they have poured the water, they have poured a fluid of unit weight 12 kilonewton, we have to consider the hydrostatic stress developed by the fluid, which is nothing but 12Z, right? So at Z is equal to 0, right? We'll consider this one as Z. Okay. because we need to consider that one as Z or this one as H. So we'll consider this one as Z. At Z is equal to 0, PA will be nothing but minus 2C root KA plus KAQ. What they have given? They have given that the angle of internal friction. They have given the angle of internal friction as 0. Since it is a clip, the angle of internal friction as 0. Therefore, K will be equal to 1 minus sine 0 divided by 1 plus sine 0, which is 1. Right. Therefore, at Z is equal to 0, PA will be equal to minus 2 into C, which is nothing but 20 root 1 plus K is 1 into Q. Q is nothing but 30 kilopascal. With this, we will get minus 10 kilonewton per meter square. So at the top, it is minus 10 kilonewton per meter square. Right. If you see this point, we will take it as Z naught. Right. So at Z naught, value of active earth pressure will be equal to 0, which is PA equal to 0. PA is nothing but 18 Z naught minus 40 minus 12 Z naught plus 30. Right, 18 into Z, which is Z naught, minus 2 into 20 minus 12 into Z naught plus 30. So we'll get 6 Z naught minus 10 will be equal to 0. Z naught will be equal to 1.66 meters. So the value of ZC will be equal to 1.66 meters. So this one will be ultimately, this height will be H minus 1.66 meters. Right. At depth H, just total depth, right? At depth H, PA will be equal to, we are taking Z equal to H now, right? PA will be equal to Ka gamma H, Ka gamma H minus 2C root Ka minus 2C root Ka minus 12H minus 12H plus KAQ plus KAQ. Right. So with this we get Ka gamma H, which is nothing but 18H minus 2C root K, which is 40 minus 12H plus KAQ is nothing but 30. So from this we get PA will be equal to 6H minus 10. Right. So for unsupported depth of excavation, total active thrust must be 0. Therefore, PA should be equal to 0. So from this pressure distribution diagram, total active earth pressure PA will be, total active pressure we will take it as PT. PT will be area of two different triangles, that is half into base into height. for triangle 1 half into base, which is nothing but minus 10 into height is 1.66. Yes. Plus for the second diagram, half into base into height. Half into base 6h minus 10 into height, which is nothing but h minus 1.66. H minus 1.66. Right. Yes. So total active earth pressure should be equal to 0. Therefore, 1 by 2 into 10 into 1.66 will be equal to 1 by 2 into 6h minus 10 into h minus 1.66. So if we solve this equation, we'll get h as 3.33 meters. So the depth of unsupported excavation will be 3.33 meters. In this question, they have asked us to find out the force distribution diagram. So if you see the diagram, weight of the wedge will be acting downwards and coercive force will be acting along the failure plane, which is C, and P, which is the reaction force between wall and the soil. So reaction force by the wall will be given in this direction, that is P, and the reaction force on the failure plane. Reaction force on the failure plane will be given by this one R. So if you see the options, option C is the right answer.